this video we're going to look at solving compound inequalities, but we're also going to graph them in this video. So we'll look at both. That way we can at least have an idea. And then I'll do a separate video for interval notation. Let's start with this though. There are two types of absolute value, or not absolute value, compound inequalities. There's two types. All right, so one is an or. Essentially, you're going to have an inequality, or two separate inequalities, and there will be an or in the middle, and then you also have an and inequality. Now, let's start off with the or category. The important thing to note here is that if I have a graph of a compound inequality, let's just say, I'll give you a quick example. Let's say x less than -4 or x greater than 4. Okay, so then let's say over here I have -4 and then I have +4. All right, the graph of those would be done the same way we've done in the past, except now we're actually going to combine two graphs in one. So essentially, just a quick thing to memorize about or, the two graphs are going to point opposite ways. Because if x is less than -4, that's going to go to the left. And if x is greater than +4, that's going to go to the right. So or inequalities point opposite directions. Now from that, you could probably guess what and's going to do, but I'll show you anyway. So let's say we have a graph. I can give you the same type of setup. I'll even use the same numbers. Now it would look something like this. We could say, let's see, we could say x greater than -4 and x less than 4. So here's what that would look like. We'd have -4, +4, open circles. But now, if something's bigger than -4 but less than 4, that would just be this area in between. So they're going to connect. All right. Now, when we do the and problems, I'll show you another way you could see and written, like another format. But just a quick note, or the graph is going to point opposite directions, and you're actually going to connect your 2 points. All right. So let's start off with an or inequality. So or inequality. Now, let's just start with this one. Let's say 3x plus 4 less than or equal to 10, or, which I'm going to just emphasize the or in the middle. You probably don't have to be that dramatic about it, but I will, or 5x greater than 45. All right. Now, when we want to solve a compound inequality, essentially we just solve this side of the or, then we solve this right side of the or, and then we'll have our two answers, okay? And we'll have or in the middle. So on the left, we want to isolate x and get x by itself. So which one do we want to move first, or which part do we want to move, the 3 or the 4? That'd be the 4, so we're going to subtract 4. This is just solving an inequality. That's all we're really doing. We're just doing 2 in one problem, basically. So 10 minus 4 is equal to 6. Last step, we're going to divide by 3. That 3 is not negative, so we don't have to worry about flipping our inequality symbol. So now part of our answer is x is less than or equal to 2. Or, now we'll go over here and do the other side. And this side's actually a one-step equation. We just need to divide by 5. So that's kind of nice for us. So then x is greater than 9. And actually, let me do it all the same color so I don't confuse myself. All right. Now, in this problem, we're saying that x is less than or equal to 2, or x is greater than 9. So let's look at how that would actually apply to graphing. Okay, so let's do this. I'll try to do it as quick as I can to save some time. Here's a graph. Let's just put, so I'll rewrite it. X, what do we say? X less than or equal to 2, or x greater than 9. All right. So we've got, let's make this point 2. we'll make this 0.9, and then obviously all these other points are just in between 2 and 9. I won't waste your time writing all those out. All right, so now, and let me just add a few over here too. Here, maybe here. All right, so now, the first thing we want to do is we want to obviously go and put a point at 2 and at 9, but you need to double check your inequality symbol just to see if it's open or if it's closed or shaded. So this inequality has a line under it, which means we do shade over 2. 9 has no line under it, so there's no shading, so there's an open circle there. Now, you can go through the logic of this and actually map it out, or you can just pretty much make yourself a note and say, hey, if it's or, my arrows are going to point away from each other. But let me talk you through it just to make sure you understand why. So if x is less than -2, would the values to the left be less than 2 or to the right be less than 2? Would be to the left. This would be 1, this would be 0, and so on. So this part of my graph is going to point to the left. Now let's do the same thing with 9. Well, if x is greater than 9, what values are going to be greater than 9? To the right on the number line or to the left? It'd be to the right. This would be 10 and 11, 12, so on. So then this graph is going to point to the right. So this is how our graph would actually look. This would be the graph of this solution for our inequality. Let me find another one. Let's maybe do one of each. So let's find one. I think this one's a pretty good one. And I mean, these can get more or less complicated. I'm just probably going to stick with some of the basic ones. Let's just go with this one. All right. So we have 3, -3y, plus 8, less than or equal to -7, or 10y minus 3, less than or equal to 33. And actually that's -33. All right, so now once again, I just want to solve each of these inequalities separately, and then I'll have or in between at the end. All right, so on the left side of my or, first I will subtract 8. We know we got to isolate y, but first I'll subtract 8, and then we'll move that -3 in a second. All right, I'm only subtracting, so don't worry about the inequality symbol. -7 minus 8 is what? -15. Now, watch what happens here. I need to divide to get rid of this -3. What type of number am I dividing by? That would be a negative. If you divide on both sides by a negative, or multiply on both sides by a negative, that inequality symbol is going to flip. So this inequality symbol flips to greater than or equal to. Then we'll divide -15 by -3 and get +5. Or, then we'll do our other part of the answer. All right, so now let's go back up here. It's pretty much the same situation. This is a two-step equation. We're going to add 3, 10y less than or equal to, let's see, that would be -30. Then we will divide by 10 to get y by itself. That's a +10, so this symbol will not flip. So we've got y less than or equal to -3. All right, now I would actually probably switch these two around, but I'll show you that when we do the graphing. So here's my answer. Let's look at the actual graph. Now, when I rewrite these answers, for me personally, I like to write them from least to greatest. So I would do the y is less than or equal to -3 first, then say or y is greater than or equal to 5. But that's just because if I don't watch out, I just get stuck in a pattern. And when I do the graph, I don't know why I do this, but I'll just read it and put the 5 over here and the -3 over here, which is not correct. So if you want to, just rewrite your inequality answer and just put it in order from least to greatest. All right, so now obviously we'll have a bunch of points through here and here and here, but I'm just going to do the main ones, -3 and 5. All right, so we're going to go to -3. Should we have an open point or a closed point? It should be shaded because there's a line under the inequality. Same thing with 5. Now, if it's an or, I can kind of cheat this and say, well, they're going to go opposite directions. But let's just make sure that makes sense. Y is less than or equal to -3, so that would be to the left, so that part's good. Y is greater than 5, so that should go to the right, so that part's good. So there's our answer. All right, so now let's go to an or example. And, if you're noticing I'm not doing some of the multi-step problems, I'm just going to assume that most of those we'll be able to handle. So let's go to and inequalities. So and. All right, so remember these two, or this graph will be connected, okay? So the lines will actually look something like that, where instead of the arrows pointing away from each other, they're going to point towards each other. I also want to give you another way that you could see some of these answers or some of these questions written, but let's first just do an example. That way we're on the same page. All right, let's start with 2x plus 3 greater than -9, and we've got 8x minus 2 less than 30. All right, so now once again, if you have an or an and, it doesn't matter. You're just going to solve each of these inequalities separately. So for this side, we're going to subtract 3. I'll start to speed this up. So 2x greater than, that'd be -12. Now we're going to divide by 2 to get rid of 2. X is going to be greater than -6. And my inequality did not flip because I divided by a +2. So then I'm going to have and in the middle. And in a second, I'll show you how to rewrite this, but let's just continue. All right, on this side, 8x minus 2 less than 30. I need to add 2 first. Add 2. 8x less than 32. Then we will divide by 8 on both sides. X less than 4. All right, so we're good to go. Now, I'm going to rewrite this just to show you how this may be rewritten, and then we'll actually do a problem in that format. All right, but let's go to the actual graphing. Let me show you how to rewrite this. All right, so let's start with what we just got. We said x is greater than -6, and x is less than 4. Now, here's how this ends up being written if it's an and inequality. Essentially, your x is going to go in the middle, and then we're going to take this, we're actually going to bring it down and apply it to this same x value. So we're going to say x less than 4, just like we would normally read it. Okay, so that part, we pretty much just took out the less than, and we put that less than 4 on the right. But now, since this is an and, we can actually take this and bring it down here as well. Now, in order to do that, what you actually have to do is flip the x. You have to flip this entire thing. So instead of x greater than -4, we could write this -6, flip the inequality, less than x. Because we're still saying the same thing. We're just flipping it around because now we can insert this part on the left side. And we can say less than -6. Now, if you read this both directions, start with x and then read to the right. You would say x less than 4. That's what we had right here. Now start back at x and read to the left. X greater than -6. Well, that's what we had right here. So we're saying the same thing. This is just a condensed way to write it. All right. And how I personally view this is I like to say x is in between 4 and -6. So watch what happens when I graph it, and I keep that in mind. So if I've got some values, let's just say, I don't know, we'll make it here, and then there's obviously a bunch of stuff in the middle, and on this side, and on this side. So now let's put -6 here, and let's put 4 here. Now, if we graph this, watch what happens, especially if you consider x is in between these two values. Watch what happens when I graph this. When I put a point at -6, it's going to be an open circle because there's no line under this inequality. Same thing for 4. Now, if my answers are in between -6 and 4, that means all these values in between -6 and 4 are the answer. So I like to really memorize it that way to give myself a hint that these two, this graph is going to connect. because all these values in between -6 and 4 are going to be the solution to this problem. So now let me give you one that's already set up, just so you can see it. I'll actually even do a hard one for you. So, well, let's not. Let's keep it simple. All right, let's say 4 less than 3p plus 4 less than 19. Actually, let's do this. Scratch that. I don't want to do this problem. Let me show you one where the inequality symbol flips. Let's do this one. Let's say 28 greater than -2 minus 10m greater than or equal to -7. That's a lot better. All right, so now you're probably not used to seeing this type of setup because everything's condensed, right? Now instead of and, we don't have an and or an or in the middle. So here's how we go about solving this. We're going to solve and isolate m, but we're going to keep m in the middle. Now, what that means is this. If we have to well, let's just start with the middle. Ignore everything else except for this middle part. How would we get rid of -2 or -10? Well, -2 we would add to, -10 we would divide by -10. So which one do we start with? We start with the -2. So if we're going to add to, we're going to add it in the middle to cancel, but then what we do to one side, we do to the other. However, there's now two separate sides to this problem. So we're going to add 2 on the outsides as well as on the insides. All right. How I like to view this is I like to act like I'm pushing everything out to the left and to the right instead of pushing everything into the middle. So you're going to isolate the middle by doing this. Whatever you need to get rid of, you're going to push it out to the right and to the left to keep everything balanced. So once again, let me start from the top. So once again, I want to isolate m, but I want to keep m in the middle and push everything else out to the right and to the left. So if my first step is to add 2, I'm going to push that 2 out to the right and push 2 out to the left. All right. So now I end up with 28 plus 2, which is 30, greater than -10m greater than or equal to -5. So now, once again, I'm going to take the same approach. I want to isolate m, so I'm going to push the -10 out to the right and to the left, and I'm going to divide to do that. Now, this is a compound inequality still, which means it's an inequality. So if you divide on both sides by a negative, both of these inequality symbols are both going to flip. So here's what happens. 30 divided by -10 is -3. This flips to less than. M is in the middle. This flips to less than or equal to. And then we have -5 over -10, which is just 1/2. So that is my answer, which I know that's a lot to cover. But once again, this is a common setup for and inequalities. So now let's look at actually how to graph it. So we said -3 less than m less than or equal to 1/2, I believe, right? Yeah. All right, so now let's make ourselves a number line. Okay, let's put some points on here. We'll call this one 1/2, and then there'd be stuff over here. We'll just keep going. We'll say that this one's -3. Put some stuff over here. All right. So now at -3, that inequality doesn't have a line under it, so that's an open circle. At 1/2, there is a line under it, so that's going to get a closed circle under the inequality symbol. Now, once again, if m is in between these two values, then that means the graph needs to represent that. So they're going to connect. Because m is actually, the solution for m is going to be right in between -3 and 1. Well, 1/2. And actually 1/2 would be included in that since it's shaded in. All right, so this is just a quick overview of and or compound inequalities. Feel free to reach out if you get a little stuck, but that'll be it for this video.